All right, let's get this going. So welcome everyone to Stateless Implementers Call. This is number 43. Um, our agenda is quite packed today, so that's good to see. Some people are doing some good work. We'll start with the number one on the agenda, team updates. Maybe Guillaume, you'd like to go first, or whoever.
Yeah, no, I'll start. Just FYI, I'm at an airport, so if you with a very loud speaker, so I apologize in advance for the noise that is guaranteed to occur. Yeah, I've been mostly working on two things. The first one was assisting Carlos with the preparation, like we're trying to reactivate the execution spec test for Verkle to make them binary tree compatible. So working on the PR, and then also worked on proposing a new PR that has to do with gas accounting. So it's not statelessness really, it's more like stemming state growth. But yeah, it's so the EIP is 8032. If you are curious, have a look.
So from my side, I've been working on what Guillaume just said. We fixed so far almost every single test case. The only thing that are left or are unaddressed so far is state diffs in one side. And I'm not sure if state transition is there entirely, at least. But everything else should be working out of the box. We detected some bugs in the implementation of the binary tree, which we were able to fix too. And we did some refactoring also, maybe not crazy, but slightly decent, I would say. Aside from that, I've been also working on Bloatnet, and I've been also working on pushing benchmarks to East in order to be able to run them within the software that Camille from Nethermind is creating. And on top of that, we have mainly been discussing some topics that will be touched later in this call.
Cool, thanks. Anyone else?
I'll go for Bezou. So Karim is not here today because he's off, and so he told me that he was still working on transition, and that he's been waiting for some returns on tests for binary trees. And I was mostly working on the past month on gas optimization, so another subject. But I'll be back on stateless now, so I'll be taking probably the subject on transition as well from Karim. But yeah, so we're waiting for test cases.
Is it test cases or is it like being able to build a test net?
I think it was perhaps the test net that works on
Right.
binary tree.
So regarding this, I forgot to mention, I talked to Perry and they have zero bandwidth for us right now. So they said just build your own kurtosis config and try to make it work. So I hope we're gonna be able to tackle that this week with a Besu image. Do you know when Karim is coming back?
Tomorrow.
Okay, so me too. That's great. So we can do that.
All right, great.
Do we have a rough timeline for when the testnet could be online?
Last June. So yeah, no. I mean, it could be. Karim is from what I understand, talking to him, Karim is more or less ready to go. But yeah, we have to write a kurtosis config, and there's very few people in the world that know how to write your own package. So we're gonna have to figure this one out. So even if ideally if we had the memo that we were supposed to work on kurtosis ourselves, we would probably have started some time ago. But currently, it could be a 5-minute job. It could be a 3-month job. It's pretty hard to say.
Okay, good. Yeah, I'll join in with an Ethereum JS update. So we were able to get a grant to get Ethereum JS going. So we're mostly in maintenance and like security mode, as it's an underlying debt for many things. But we still would like to help out with testing efforts in some capacity. The main thing that we see ourselves being able to do is just joining a testnet, but in a stateless fashion. So at least we would have a minimal like stateless client that can join at some point. We're not going to put as much effort. I mean, it's a small like team that just does maintenance, but we still would like to help doing that whenever that's available.
That's going to be quite difficult to do because binary trees don't package any proofs with them. It's supposed to be a stepping stone for ZK proofs. So as long as we don't have working ZK proof execution, I mean, we could build this, but I think it's a bit too much of a step for a first testnet with binary trees. I don't think this is going to be possible to do this unless we find a way to generate proofs and forward them to you so that you can, like, I mean, Merkle proof, so that you can execute them. But I would say that's probably a distraction at the moment.
Okay, yeah. We definitely don't mean to distract. So what we could do is what we had done in the past is just stateless execution without proof verification. So at least we could, validate state changes and things like that without, obviously it wouldn't be a secure client, but in the past there were, we were able to help the efforts by just executing the blocks without verifying them. So if that's helpful, we can do it. But if it's not, we're not going to bother.
Yeah, I don't think that's going to be possible because we also don't have any witness. So if we're rebate on top of BALs, we could do this, but that's yet another rebase that on a piece of code that is still in active development, at least in Geth. The BAL is still being reviewed, and as far as I know, I could be wrong, but my understanding of the situation as of last Tuesday is that Geth is really the only EL to have an implementation of a block access list. Could be wrong, but that's my understanding. So as long as we don't have that, we can't even do stateless execution without checking for the proof. So yeah, I think that's not gonna fly. I mean, like I said, we can think of something, either do ZK proof execution or rebase on top of BALs later. But I would say for this testnet, I would focus on writing the kurtosis package, get Besu to work, see if we can get Geth to work on that as well. And if we get all that, that would be pretty good already.
Yeah, so that's good to know. So then the upcoming testnet is not going to have execution witnesses and is not going to have like any kind of proofs, but it's going to have a binary tree structure. That's all, right?
Exactly.
Good. Yeah, that's relevant. I wasn't aware of that. So perfect. Any other team or client updates? Right. Looks like we're good on that front. I'll proceed with number 2 of the agenda. I linked the agenda, by the way, on the in-call messages if you guys want to consult it. But number 2 is updates on binary tree, TAWN, self-fixtures, consumption, progress. This is from Carlos.
Yeah, thank you. So at the point we are at, most of the things that are not passing are just related to state diffs, which we currently don't support. So I'm not sure what's the best way to proceed now, and what we want or what we don't want. One of the clearest things that we need from the testing perspective is we need to heavily rebase, or I mean, start a new branch, basically. The main Verkle branch from East, which is currently stuck at, I don't remember what fork. Well, the fork name is Verkle, but I mean, I'm not sure which one it is in reality behind the scenes, but it's certainly not even close to Prague.
It's probably Shanghai, so it's only 2 forks down, but yeah, significant changes happen.
Yeah, so this is one of the things that we need to do. But I know East is migrating to EELS, I think. I mean, sorry, there's just too much names, but I mean, they are migrating their code base. So I'm not sure how this will end up. And I think Mario is here. So maybe we can briefly discuss this because I'm not sure if the code base will change significantly, but if it does, we have a problem because all of the Verkle stuff is fairly fragile. And if we move it, we risk like a much deeper refactor than we anticipated.
I honestly have no idea how much work is in the Verkle branch, to be honest. But I assume it's like way out of date to be reusable even. Maybe it's better to start from scratch. I think we need an input from someone from the team that has worked on this branch, and I think that Spencer is not in this call today, but I'm not sure. Do you guys have any idea of what were the changes in this branch?
Yeah, I mean, I can't give you the exact code changes that this corresponds to, but I can roughly explain what this did. And yeah, the one that worked. So Spencer was the main guy on this, but Dan also worked a bit on that. Sorry for the noise. I hope it's not too loud. So the things that did change is we changed the way that we input data. So normally, when you have the block transition test, you get an alloc, right? Like we do for Genesis allocs, which is a bunch of accounts, storage, code, etc., etc. And you output also an alloc. So you get an alloc as input, which is the pre-state, and also the block, or at least some description of what transactions need to go inside the block. And then the output you get another alloc, which is the post state. This can no longer work in Verkle or binary tree because the tree is unified, and there's a consistent hashing technique. But because they're not in the same tree, because everything is in the same tree, you have no a priori knowledge of what is an account and what is a storage slot. You can guess most of the time, but you can't go around the fact that there could be an account that looks like a storage, some storage area that looks a lot like an account. So yeah, ultimately you can't do this. So what they did was to create a new an extra field in the pre structure where you have the alloc, but you also have the list of key value stores that you would be using to reconstruct the Verkle tree, or today the binary tree. And then you would output two things. You would output the alloc again, but it's empty because we know nothing of the MPT. And then you would also output the Verkle tree, or the binary tree now, which is just a list of key values. Because Verkle had a very weird way of computing its keys that was really heavily, that was math heavy, you needed to call back into Geth to ask Geth to do the computation, like the tree computation, the key computation for you. That is no longer necessary because, if I remember correctly, we use SHA-256 now, so the key computation could be implemented in EELS or in Steel. So there would be a great deal of simplification, but you still need to have this dual input, dual output system. And from what I understand, this is the only thing that really needs to be brought over. And then, of course, there's all the test definitions that Ignacio did, but I assume this would be automatic. Like, you define a new fork, you say those tests are active at this fork, and yeah, that's pretty much what I remember.
That is great. Thanks. So I think it sounds like the changes are localized. I got a feeling I know where they might be. So I think my recommendation would be that we wait until the weld is finished. We're pushing for it to be finished this month. So one of the advantages is that we can create a Verkle branch over there, and then we can do all of the changes in EELS, and then we can bring East into there and just automatically create the tests. And from, I think it will be a lot of work to pick apart the changes from the branch in Verkle, but I think it's still doable. But I think we should only do it once, and only do it once we have welded into EELS. Yeah.
So just to ask,
Yeah.
Oh, sorry.
Sorry, go ahead.
I was just going to say, I completely agree with Mario. The only question that I had at this point is mostly related with all of the fixture system, and not only that, but mainly also focused on. I'm not sure if your new code base has its own like virtual machine written in Python or something like that. At least that's what I understood. Maybe I'm completely wrong. But if that is
Yeah.
the case, does this mean that we will need to implement the EIP in Python in your code base, such that then we can do all of the backporting? Because now Geth is responsible, right, for creating the fixtures and then consuming them, and we can share across clients. But we only take care of the implementation in Geth. But if I understand correctly, now we will need to implement it both in, well, in Geth it already is, but we will need to port it to Python, right?
Yeah, that's the entire point of the world. So the thing is that this thing's, so yeah, that you would need to do that even if you are, even before the world, you still need to do this because we rely on EELS as the canonical implementation. So for the EIP to progress, you still need to do this Python implementation. Anyway, so I think it shouldn't be that hard. And what's going to allow us is to just create fixtures more easily and be like, be able to fix the spec if there's any like issues in the spec, and go back and forth in rapidly iterating on tests more efficiently. So I think in general, it's a good thing. But just to come back to the first point, I think, yeah, that is the case. You need to implement this in Python in EELS, but we can assist you on that if that's the main issue.
So some information. Back in the day, Ignacio did do an implementation, a Python implementation of his EIP in not in EELS but in Python. So we already have something. And back in the day, Geth and like there was a bunch of test vectors that were not made with EELS, but Geth, the Go implementation outside of Geth would find exactly the same outputs as Python. So as far as I know, they're fairly compatible. Now, like Carlos said, we did fix a few things, so maybe we broke compatibility at this point. But overall, it's just a matter of finding where that library was and bring it into EELS, which might not be that hard. We shall see. The only thing that we need to handle in EELS is how to be able to have a different kind of tree, maybe a different kind of account model. So it might be involved, but yes, if you can help, that would be great. I had another thing. Oh yeah. So one piece of detail I did forget to mention before is that even when we created that branch, the incentive was strong, or the suggestion was strong to start using EELS, but we didn't do this once again because of all the cryptography that was difficult to implement in Python. So we were doing Geth. We were using Geth as a filler. If we can delete some of that code inside Geth, that Geth is no longer expected to be a filler, that would simplify. I'm not sure actually how much code is specific to the filling. Probably none actually. But if we could find some more code to delete, that would be very nice.
So yeah, thanks. I think given the weld situation, I think what we can start working on is the EELS branch for this. But the main problem I think is that no one in the team at the moment is like super familiar with binary trees. So it would require input from you guys to help us out with the implementation. Did I understand correctly that this does not require any new cryptography primitives? Because that simplifies the
Indeed.
implementation.
It requires new cryptography primitives in the sense that we use SHA-256 instead of Ketchak, but it's not new in the sense that it's not something impossible to find as a Python library.
Okay, all right. Let me bring this back to the team. I think the main focus that we have right now on EELS is block level access list. But if we can coordinate starting a branch in EELS, we can work on that. And then once the weld is done, we can just bring the tests in, and then it will become a little bit simpler to work on the specs and tests. So I think it's the main thing to do is the EELS branch at this point. Rather than focus on the tests. Yeah.
I just realized all of a sudden, because I happen to be the first external contributor to EELS, and back in the day, when you wanted to implement a fork, you just copied everything, and you just made your changes in the copy, which makes sense for what EELS is designed for. But the problem is if you start doing this as a fork that is going to move, because it's not going to be scheduled, next or even two forks down. How do we maintain it long term?
So the team is like very aware of this process. So this has been I think it has been routine. So basically they take the changes, the commits, and cherry pick and move them over to the new fork. But this is something that I don't think you should worry about just now. You should just start working on top of Osaka, which is fairly stable. Or were you guys planning on starting on top of Amsterdam? Because that's a moving target. So I would recommend we just start in Osaka. And then when the time comes and block level access list becomes more stable, we can move over and cherry pick the commits on top of Amsterdam. The team already knows how to do this. It's not a problem. But yeah, just to get things moving, I think we should implement this on top of Amsterdam, in my opinion. Yeah.
Wait, because you say you're going to cherry pick the commits, but they're going to be against the wrong type of files, right?
Yeah. That's right. I mean, it's not as simple as copy pasting, but it's this has been done before. So I don't think it's gonna be an issue. Yeah.
Okay, well, I guess we will find out when we start implementing EELS. So I guess to close that topic, at least as far as I'm concerned, is where do we start? We start. No, you guys are gonna start working on EELS, and we help you. Is that the plan?
So I think we're packed right now with issues to resolve on the weld and also on block level access list. So it's gonna be very hard for us to start this week or even the next one. If you can start, I mean, that would be ideal. I think the only thing that you have to do is just create a new branch, forks. Maybe let me see what would the name. It doesn't matter the name, right? We can basically start a branch in any of your forks of the repo, and I think that would be a very nice start. Yeah.
Okay, and when this happens, right? Sorry, the question is, what about weld? Is that going to impact EELS? Like if we start working on EELS, is that going to is weld going to introduce a ton of changes?
Yes. So basically, what's going to happen is that every branch on EELS is now going to have the entire set of tests. So basically, the goal of this thing is that we have a single mono repo that contains both the specs and the tests. And the key part of improvement is that when you're working on the specs, you now can immediately run the tests without having to go into another repository, reference your branch or reference your fork or whatever. you can simply just run the tests as if they were unit tests, and then you can get all the coverage that you need. So this will help you guys in the end. So when the time comes that we do the weld, the branch that you guys are working on will be out of sync with without the tests, but we can do that work for you. So we can, once you guys have the branch, the binary trees branch, we can come in, just plug the weld changes, and it should be like seamless for you. So that's why I'm suggesting that we start with the spec implementation in Python in EELS, so we can later just come and plug in the weld changes into that branch, and we can continue the work. And now you will also have the tests in there. Does that make sense?
Yep, absolutely. Thank you.
Nice. I think that closes the topic. Thanks, everyone. That's for point number 2. Next in line on the agenda is number 3. So discussion on basic data, inclusion in the 3 by Carlos.
Yeah, I added that as a reminder, which Guillaume asked for. We were, I mean, I don't recall the exact details, but we were discussing about the basic data and the structure that basically an account had when it was laying down, a contract had when it was laying down within the tree. And Guillaume basically noticed that now it maybe doesn't make sense to have like, let's say, quick access between quotes to the first let's say leaves of the contract storage in an upper layer, and it will simplify, let's say, decently the spec and the understanding of the binary tree structure. And basically there was this I wanted to basically discuss whether we remove this or not. I mean, since Karim is not here, maybe this is not the best day, but I don't know. Maybe Thomas has some insights or whatever.
Yeah, if Thomas not asking questions immediately, I do have one. I don't remember the context. Could you re-explain? Like, we want to get rid of basic data. That kind of rings a bell, but at the same time, I don't remember the rationale.
The rationale is we had all of these set of leaves that lay together in the same level, such that you can access the first bytes of the contract storage. And I'm not sure which was the exact discussion we were having, but we basically said that it would be better to just get rid of this thing because it was providing no upside, and it was bringing complexity from the other side. I can revisit that and we can discuss it on the next meeting if it's better, because I don't remember, to be honest.
Yeah, I'm not sure I get it either, because basic data is just we've compressed like 4 fields into a single field. Like I can recall exactly which one, like version, code size, nonce, and balance, I think. And then there's are you referring to like the 64 or 128 initial storage slots that we put into that first sleeve? So that's a different thing than basic data.
Yep. You're right, but it's this one.
Okay, right. So you're referring to store the first 128 storage slots that are stored into the initial leave. You would push them to another leave completely, right?
Yeah, I think the goal was just to not have to not duplicate them or not have them treated, let's say, specially or whatever.
Yeah, exactly. So now I remember, but indeed, like communication got garbled a bit, which is why I was confused for a sec. There's the code, right? We have the concept of right now the code is deduplicated in like you create a contract that already exists. It's stored at a single location in the database, so you don't have to store it twice. But if in the current model proposed for Verkle trees and that binary trees inherit, because you have this account, like this header group, where you do have the basic data, you have the first 64 slot, and you have the first 128 chunks. If you write the same the same code multiple times, you are going to duplicate at least the first 128 28 leaves. And because the code you use some offset, but you also use the address, actually you will duplicate all of the code. So what we wanted to do actually is to say, but that was already something suggested by Ignacio a few months back. What we would do is only like forget the address part and only hash the code hash or something similar. So that the code is again deduplicated, because for Verkle trees, like Verkle was saving a lot of space, but because of the code duplication, a lot of the space it could have saved on top of that was actually wasted. And it would be a good idea in spite of the potential savings, because you only have to load one header group to execute the first 128 leaves. It would be a good idea to actually put the code separately so that it's deduplicated if you need it, like if you deploy it twice.
Okay, that's fair enough. So to be clear, we're talking about the code chunks strictly. No storage and no basic data, just the code chunks. It would be entirely independent of the basic account leaf, and therefore they could be pointed to by multiple accounts.
Exactly. And potentially we could also move more storage inside the header account. But yeah, I guess we need to think that a bit more thoroughly first.
Yeah, fair enough. Okay, cool. That makes sense. Are we moving that discussion to maybe people can do a bit more research or thinking about this, because it seems like more of a new proposal that we've just clarified, unless someone wants to chime in? Were you going to say something, Guillaume or Thomas?
I think it was Guillaume that was going to say something, but he got muted.
Yeah, no, but I was just, I mean, yeah, I agree. We should maybe give more time to people to consider it. But yeah, that's all I was going to say.
Okay, good. So let's kind of bookmark that for the next discussion or further discussion. I'll move on to step 4 of the agenda. Then, Carlos, again, it's Bloatnet updates.
Yeah, so on that side of things, things are going pretty nice. We finally got unblocked on merging PRs to East. Thank you, Mario and Luis, for that. We also submitted some fixes, especially on the stop contract side of things and on the benchmarking one. The situation now is we have pretty much all of the multi-opcode tests we are interested on. We have implemented at least the most serious or directly related single opcode tests related to scaling L1. So basically, S-store onto the biggest ERC20 contracts and S-load into empty or most likely empty storage slots also in the biggest contracts. So now the goal is to see those PRs merged and see how do we integrate that together with Camille's tool from Nethermind. I don't want to bring a lot of discussion here because tomorrow we will have a call about that between all of the parties that are related to this. But it's basically just to say that there's a lot of work done, but might have to be completely refactored depending on what happens here, because we have East, then we have the benchmark from Camille, the benchmarking tool from Camille, and then we have all of the stuff that we're putting on the top of East. And so those three pieces need to like puzzle up correctly together. And it's not clear at all that this is going to be the case or not, because no one has seen much of Camille's tool yet. So for instance, stop contracts cannot be specified between different tests. which is a major issue in my opinion, because it defeats the purpose of having stop contracts as a feature, basically. But yeah, that's sort to say that this is where we are at benchmarking wise. And so on the other side, which is syncing tests, we've had great help from Patty, and we have actually seen Red and Erigon start interacting with us a lot more. It seems they are working on debugging the main issues that they have, in this case, Red, with syncing their client and all of the pinning issues related to that. So far we have run like 5 or 6 benchmark runs, and they haven't been able to lock into a single peer at any point. So they are trying to debug what is going on, and hopefully we will get them on board. Yet to be seen what happens with Erigon, although they seem to have someone that is full time now working on this, or at least that's his main goal. So yeah, I will update as soon as we have some progress, and hopefully we will have the 5 clients soon, so that we can benchmark or run all of the benchmarks for all of them. Because otherwise, I will need to get back whenever a client is ready and I rerun the benchmarks again. And considering how heavy the snapshots are and everything, I would prefer to just not need to do that, let's say. So yeah, that's the TLDR for Bloatnet.
Cool. Thanks. Any comments or additional thoughts on that before we move to the next point? Sounds like we're good. All right. The next one is from Han. Findings on post EIP 6780 self-destructs.
Yeah, just let me share screen quickly. Right. So it's gonna be a quick one. So as part of the initiatives on continuing the state analysis, so I guess on the side of the Aspire as well. So we wanted to find whether there's a group of state that we can like remove or expire without much consequences, or like people just don't care. And one of them could be self-destructs. So that's why we wanted to like analyze the self-destructed contracts. So the findings are pretty interesting. I mean, not very interesting, but it's pretty straightforward. So this is the self-destruct count based on the network upgrade from Genesis to some blocks up until I think block 23 million. So yeah, we I guess we only care about Dankun, like post Dankun, but just as a quick revisit on what has happened in the history. So so the first one, I mean, you can see that that's like a huge increase in during the DAO fork, which is block 1.9 million to 2.46 million ish. So this is the infamous DOS attack. Basically, people at that time, like there's a DOS attack on empty accounts, and I guess it like Gav nodes at that time sort of got like out of memory, if I'm not mistaken. So yeah, that's one attack done using self-destructs. And then moving forward, we have the, I guess this period is the gas token arbitrage period, where people like when the gas price is low, then they would store stuff, and when the gas price is high, then they would self-destruct and get the refunds. So yeah, this should be the period. And then once some of the EIPs got included in London fork, then we don't really see those stuff happening anymore. And then finally, I guess what we are looking at right now is the post EIP 6780, which is activated in Dankun. So as a quick reminder, so after this EIP got activated, if an account is self-destructed and created within the same transaction, then it won't appear, like it won't be added to the state try. But if it's not the case, then the account won't get self-destructed. Like it will still remain in the account try. So those are, I guess, my intuition is that they are mostly garbage, but I could be wrong. there could be some users that are calling self-destruct, but then still using the contracts. But anyhow, so if we look at post-Dakun self-destructs, there are up until right now, there are about 2.7 million of them. There are self-destructed, but they are not deleted from the state try. And in total, in terms of storage slots, it's about 380,000. So all in all, it's 1% of the total accounts and 0.03% of the total storage slots. So if we can find a proposal or find a solution that removes the self-destructed accounts, given that like users are okay with it or the communities are okay with it, it doesn't yield that much of an outcome in terms of like state expiry. So yeah, there could be other things that we can find out, but here's just the finding that we get for now. So yeah, so that's pretty much it for the quick sharing.
I have a quick question regarding this last slide. Okay, so that's 2.7 million, which indeed is nothing compared to the, if I remember correctly, about 200 million accounts. But this being said, what is the rate at which those contracts self-destruct? Get created and then someone tries to self-destruct them. Is there a waning in the frequency? Like, is the bulk of those 2.7 million just like in the first month after the Dakun, or is it kind of constant and we can expect more contracts to get created with the expectation they would be self-destructed, but do not?
Okay. I don't have the data on top of my mind right now, but when I was collecting, I do recall that I think the first few 100,000 blocks, which is I guess few months-ish after Dakun was activated, there were a lot of self-destructed accounts, like self-destructed unique accounts. And then towards like I guess Spectra, the number of accounts that got self-destructed was like slowly decreasing. But yeah, that's just what I've noticed, but I should get the accurate data. And I guess in regards to frequency, again, I don't have the data right now, but from what I like, again, from when I was gathering data, I don't notice a lot of like self-destruct counts, right? Because this one is based on self-destruct counts, but in terms of unique accounts, it's about 2.7 million. So maybe there are some overlapping self-destructs that's calling the same account again and again, but I would say that the frequency is very low, like maybe less than 5 times per account on average, let's say. But again, this is just an intuition. But yeah.
Yeah, I mean, I understand, and you're probably correct not to really care about to say we shouldn't care. I'm just saying, what triggers my question is because we also have this idea that in Verkle that we would not delete zero storage slots, and if we do this. It doesn't look like much every time at every block, but it accumulates. And Gary did some prediction and says, well, after a while, it's going to be pretty bad. So yeah, maybe if that thing keeps coming at a high enough rate, it might still be worth deleting those accounts. But yeah. Nothing seems to indicate this so far. It's just it might be worth to plot the rate to see that it's indeed tending towards zero.
Okay, I'll take note of that. Right. Okay, I think that's it from my side. I'll pass it back to Gabriel.
Perfect. Thanks a lot, Han. All right, we're at the last point of our agenda. We're right on time. The last one is from Guillaume. It's about modernizing these fixtures for Verkle that currently sit under a separate brand.
Right. So what I meant is pretty much redundant with the agenda item we already got by Carlos. So miscommunication again. This being said, I think there's a need to revisit the fixture themselves and the test Ignacio wrote to see if we want to keep everything. Like for example, do we want to keep 4762? Yes. Do we want to keep the test for the state diffs? Probably not. Yeah, so I'm just sharing that thought. Maybe someone has a comment on this.
I mean, if we don't keep at least all of the state diff stuff, we can already share with Karim all of the fixtures that we are generating, and we can start comparing the implementations. If we want to aim for state diffs, then this will take quite some time.
Okay. So just to be clear, the state diffs are the only thing that do not that are preventing us from shipping that PR on for gas, right?
So state diffs is now from the 500 and something tests. We are passing more than half. Then almost half of it is state diffs, and then we have like, let's say 5 to 10 remaining that I need to look at. But we should be like almost ready if we exclude state diff tests. Sorry.
Right, and presumably, if we do that rebaseline, oh yeah, but we will need East. So yeah, okay, we still need to be able to provide Karim with some test feelings.
Because
Okay.
that's independent, right? Like at least they can check what it's failing with our fixtures and what not, and we can put the two implementations in common and make sure that there are no failures on any of them, or spot box or whatever it is.
Right. Yeah. Okay. So I think that's prime candidates. And do you remember the other test, like what the other tests that were failing were about?
I think there was something related to persistence. So like when we were doing tests that were lasting for more than one block, then we were having issues like nonsense or stuff like that. This one, I think it's related to some bug that I was trying to like catch. I mean, I can fix it, but I don't want to fix it on the way I did, because I just, as I show you, Guillaume, I think I re-implemented most of the machinery, let's say, that was already in place to do that. So I just need to take the time to debug that. But yeah, I haven't had it.
Yeah.
So.
Yeah, okay, that's fine. Thank you for doing that. It's really not a fun EIP. Sorry, a fun PR. Yeah, okay. No, I think most of it should remain, but at least we can delete those state diffs, and that's already one thing that's going to simplify the rebase anyway. So might as well delete it now. Another thing that I was thinking, I mean, okay, no, we're close enough to generating the fixtures and consuming them that I guess that's the best course of action. Okay, cool. Well, that's pretty much it for the topic, I think.
I had one quick question for Mario. Mario, does it make sense in the new repo to start working on the binary tree porting? Like it's a really self-contained thing. So I'm not sure if this is work that we can like advance already, or you prefer to put it on hold until.
No, I think this is a good idea. We can proceed with that, with the binary tree implementation, and then we can implement it in a branch in EELS. So were you thinking of doing it directly in EELS, or were you thinking of doing it in another repository and then bringing it to EELS, or you haven't decided on that?
I don't have any opinion. I would say whatever you guys tell me, I will do. Like you are the ones that guide this thing, so I will adapt to whatever works best.
So yeah, feel free to create a branch in EELS directly if that's easier for you. If you can do that, that's even better, because we can just rebase and then bring the weld into that branch. So yeah.
Okay. I mean, I will contact you offline probably, because it would be helpful to know like where should I start looking to implement that, like code base wise, because I haven't even looked at it. So yeah, if someone from your team or you, whoever, can like dedicate me 15 minutes, that would be really nice.
Absolutely. All right.
Thank you.
Good. So I think that settles it for this call, unless someone has another comment or question. Otherwise, we're good. I'll write a summary of this call and we'll do a tweet thread later this week. Any closing remarks? Otherwise, I'll just end this slightly early. All right. Looks like we're good. Thanks, everyone. We ran through that agenda pretty quickly for the hour. That's good. Good job, everyone. And yeah, talk to you all in 2 weeks. Bye-bye.
Cheers.
Thank you. Bye-bye.
Thanks. Bye.
Right.